So have you been considering the possibility of using advanced DOE tools? The traditional factorial tools are two-level conditions, say a low pressure and a high pressure, 10 psi, 15 psi. A lot of times people, when they're looking at a situation, say, well, my problem isn't linear, I need to consider more levels when I do my testing. So what are the options with advanced tools? I think they fall in really three general categories. One is a three-level design, and the most efficient and productive one that I've found to use is called a box banking design. It's three conditions, so you can look at those two extremes of 10 and 15 psi for the pressure, plus evaluate something more in the middle. There's also something called a central composite design, which takes those same limits maybe from before, but extends them with something called star points. It actually becomes a 5-condition test. So you can really refine and see your design space very well. And then the third one is a family of tools called optimal designs. Different software packages promote and have different ones available. D-optimal's been a popular one. I-optimal's maybe a more recent one with computing technology advancing. But they're highly customized, really looking at minimizing the number of test runs to maximize the information that you get out as far as terms in your final equation or final model. Why would you use those? Again, I just mentioned with the D-optimal, the third option, that you tend to use those very customized situations. The box banking, well, let me back up. The central composite designs, I think, are best if you did start with the factorial design, the two-level, two-condition one, and then you augment it with those points. And what you really do is you create that, but in a progressive or manner. So you don't throw away your original two-factor or two-level stuff. You've augmented it with some additional test points. Why would you use box banking? Sometimes the multiple conditions, it's costly to provide each variable level. And so a 3-conditional will save you maybe things, if it's a lot charge or tooling charge that really drives your cost, you can minimize that with a 3-level design. When would you use them? Again, going backwards through the list, the D-optimal tend to be highly customized. I would tend to use those if the others just purely don't fit. The central composite, again, I would tend to be through iterative testing. It would be a second phase DOE that I tend to do. The box banking, it can fit in a couple different places. Where I like to use it the most is when I look at my initial test, my phase 1 test, and I just can't do it at 2 levels, but I don't want to jump up to the 5-level CCD or central composite design right away. I like to jump to that 3-level test. It's a little bit more efficient. It doesn't test the extremes quite so much, so if that's acceptable. But it seems to be an efficient way to jump to the advanced tools instead of progressing through the two-level factorials first and then progressing to the CCD. They all have a place. The CCD and the box banking are the workhorse tools, the 3 and 5-level tests. But if you have that ace in your back pocket with the optimal designs, if you do hit a special situation, it can help you alleviate those needs and balance things the best you can. So hopefully that gives you at least a flavor of when you may want to consider the advanced tools and where they can fit in for you and the project you may have in front of you right now. If you need help deciding whether it's those or a factorial tool, give us a call here at Perry Solutions. I'd love to help you out. Make sure you get on the right track for a great learning experience with the OR Design Experiments testing.